next part to the next page. So again here, you're going to be looking at the material that you need to summarize and the questions that you need to answer as well. And I'm going to just state something about this. When you're designing an experiment or an activity, this is super crucial whenever you're going to conduct a practical or an activity. It has to be what we call fair, okay? I'll give you a good example. We're saying we want to determine how the time you spend studying affects the mark that you get. We assumed a couple of things there, which is what happens in science a lot. We assume everything else remains the same. So what we'll do is that we'll take two students, okay, you guys? We'll take two students and then we'll say, okay, you guys, we want to compare one who's not studying and another one who's going to study for like 2 hours for a particular test, and the other one doesn't even study for the particular test. There's something that we're assuming. We're assuming that all the students have ate, for example, because we know that eating affects a person in their preparation for an exam. They have had enough water, they are in the right frame of mind. In other words, if someone is stressed, they may not be able, even if they read and so on, they may not be able to produce as much as they possibly can. So we're making assumptions that all of these other things are exactly the same, but which is super difficult in reality because, listen, we can't all be emotionally at the same level in reality. But in experiments, we will not really be dealing with people, thank God. Hence we talk about using rats and labs and so on. But in most of the experiments that you will be conducting, you'll be dealing with plants, you'll be dealing with, non-living things like paper, pencils, and pens, and so on. So usually they have nothing to do with emotions. So when you are dealing with your investigations, you are going to focus on exactly what you think is a factor, and you only vary that one. Every other possible factor has to remain the same for all the experiments. All right? What I mean by that is anything that is likely to affect your investigation, all right, is called a factor. And if you want to find out what factor A, whether factor A is, how factor A in fact actually affects your investigation, then it means that all the factors from B, C, D, E, F have to remain the same for all the objects that you'll be using. And then next, if you want to find out whether factor B or how factor B affects your investigation, then it means that factor A along with C, D, E, F remain the same for all the experiments. Sometimes it will be even crucial to conduct investigations at the same time. Sometimes you may not be able to do that. You may have to conduct one after the other, depending on your available resources. But best will be to conduct experiments at the same time or your investigations at the same time. All right, so that you can be able to compare them because sometimes temperature changes even affect your investigation. For example, your ability to focus can even affect your investigation. Let's say you're repeating an investigation 10 times. You're super fresh when you begin the first investigation, but as you begin to go, conducting investigation after investigation, you become tired, you become, you begin to kind of take shortcuts and turns where you then, make certain errors and you think, okay, it's not relevant. You were nervous with the first one, so you were very, very alert. But with as you proceed, you begin to take a couple of things for granted. By the time you get to the 10th, sometimes the results will be very much off. And they'll be very different to the first one, again, due to differences in concentration and so on. So all of those things are very important that, okay, instead of having one person conducting 10 experiments, for example, we'd rather have 10 people conducting one experiment all at the same time. That could be one way we could structure the test. So the idea is to try and make sure that we keep all other variables constant. So in our case, for the guys who are studying, so we got two students. One is not studying, the other one is studying. And what we'll do is that we make sure, okay, you guys, if y'all are gonna have, let's say cereal for breakfast when you wake up, then you're all gonna have the same amount of cereal, and you're gonna have the same cereal. In case that maybe one cereal makes you a super genius and the other one doesn't, and we're gonna try and make sure, for example, even the mode of transport that both kids use is going to be the same, because one uses a taxi, they'll get to school a bit tired, and the other one is dropped off at school, then they get there fresher, and all those factors become very important when you're considering an investigation. And we do it at school, we assume all those vectors are exactly the same, all right? We assume that they're exactly the same, although in reality, they are not. That's why if you remember from the bean seed investigation that we did when we planted seeds in class, we had different results. This came about because there was differences in how you guys conducted your investigation, how you put the bean seed in, whether you have a lot of cotton, whether you had enough water, you had too much water, you had less water, all of those factors came in, whether there was enough air circulation for oxygen to be able to be used in the process for germination and all of that, whether there was enough warmth, all of those factors, they varied depending on how you set up your experiment. That's why you notice that one plant, one seed will germinate faster and grow bigger and overnight, and the other ones will stay forever, and some of them will literally drown and die and decay, and we'll see that they will never grow. So all of the small things affected our investigation, and this is the importance of a fair test. And in science, we always try to make and keep everything fair. All right. Now, moving on to the last thing that I want you to look at and to summarize is the impact on the environment of the materials that we have on them. Right. So you can just summarize on that. I cannot overemphasize the impact that plastics have on the environment. I think you'll see them in here. I'm not going to preempt them because they are the basis of the exercise I want to give you, which is going to be this one right here. So what you need to do is to read this passage right here, and then use this passage to then answer the questions that follow on there. All right, you guys. And then again, you will then look at topic 5 revision, which is on the next page, and you will go through that, and you will answer all the questions. This is all in your book. And then I included a material that I then researched and found out from elsewhere. And I would want you to attempt this because I wanted to bring out something that you guys may not necessarily have from this very textbook, because that's what the exam and the tests are going to be like. But then there's something I want to emphasize. When you look at a graph for water, let's say, let me not put an X because we know what this is going to be. So this is going to be the time that we're going to be heating the water, and this is going to be the temperature at which the water is being heated. You'll notice that the graph will look something like this. Okay, so what that means is we've got water here. The water is going to be ice, and then here is going to be liquid, which is going to be your normal water, and then here's going to be your steam or your water vapor to be precise. But what I'm really interested in bringing out is this part here. Okay, what happens is, at this part, what's happening is here the water is melting, and then here the water is boiling. Notice what this means is that the temperature does not change when water is boiling, and the temperature does not change when the water is melting. Boom, this blew my mind the first time I heard it. Let me explain what this means. For you guys, when you want to take a bath, let's assume maybe you take the boiling kettle, you put water on there. Sometimes you leave the water to boil for a long time, all right? Because it's like you see, okay, the water's heating up, there's steam coming out. I see that the water started boiling. Let me leave it for another 5 minutes so it become hotter. No. Unfortunately, what you're doing is you're wasting energy, you're wasting electricity. You're just cranking the bill up. What it means is, as soon as water starts boiling, it cannot get any hotter. If it does get hotter, it turns into a vapor, and you will not harness the vapor to bath with. All right, you guys? So the temperature does not change. As soon as water starts boiling, it's 100 degrees. Boom. And what may change, though, is maybe different parts of the water may not all be at 100 degrees. So maybe that's why you might leave it for just a few minutes. But to be honest, once the whole lot of water molecules or particles are boiling, everything is 100 degrees. Once it passes the 100 degrees for a normal liquid water with no impurities, then it means that what you're doing is you're just changing it into a vapor, and it's just going to escape, and you will not have that warm bath that you're planning to have at the beginning. So take note of this, please, that when you're melting ice into liquid water, the temperature does not change when you're doing the melting. Same thing when you're boiling water, the temperature does not change. it still stays the same. So you can already tell that this is going to be 0, this is going to be 100 degrees, but specifically only for water. These fixed points are going to be different for other liquids, for alcohol, for mercury and so on. They're very, very different. So why do I bring this up is because for this particular question, you can see a trend-ish, right? And then you can see something that's not changing weight here. It's just a hint. All right, grade 7s? All right. So if you have any questions, please feel free to jump onto the group, ask on there, and I will get back to you. But whoever understands the question and feels like they can be able to respond to it, please try. There's no problem with trying even if you're wrong, and then I can be able to correct you from there. It's exactly what we do in class. I pick a student, even if you're going to give me the wrong answer, try it out, and then I will correct you from there. All right, so there's still no difference as to what we're used to doing in class. Try it out, and then I'll still answer you from there. All right, I hope you guys have a fantastic day, and see you next week. Bye-bye.